All right. And we are live. Thanks everybody for joining us. Thank you, Mr. Cutler. It is wonderful to see you again.
You're very
How
welcome.
are you?
I'm really good, actually. Yeah, feeling festive.
Festive. I like it.
Look
at how, because just, for those who are not watching this live, it's just before the Christmas break. So what are you doing for your festivities?
Oh, it's gonna be a lot of family, some young children, so it's gonna be intense, I think.
Good. I'm expecting similar intensity as well, but a welcome intensity, a different intensity. You know what? I learned a new word yesterday. Eustress. Have you ever heard of that?
No, I have not. I'll have to go to Urban Dictionary and look that up.
It is EU stress.
Okay.
It is a healthy kind of stress.
Okay.
I didn't know there was such a thing, but anyways, okay. So not to derail this is not why people are here to learn vocabulary. It's to learn about DDoS architectures. So, all right. So this is the third and last in our series. Of course, they're all meant to be watched individually. These are meant as a fireside chat. So those of you who are wishing to learn more, or maybe you're an existing customer of ours who want to understand some of the flexibility that you have, what Pete and I have been doing is going through and just basically me interviewing Pete on different deployment models, as well as the pros and cons and what they mean to you. So with that, now what I was supposed to do is kick off some polls. We're going to start with poll number one. I forgot to announce them last time, so I'll let this run for everybody. We'll start a poll there. We'll keep that going. All right, let's dive in. So question number one. So we're talking about inline and virtual inline, which we also refer to as data path for those watching, in case we slip into different nomenclatures. What are the key differences? I mean, I think I can do the math, but then again, I work here. I'm used to it. Yeah. What are the key differences between inline and virtual inline deployments?
Okay, Mark. Well, let's not assume that, excuse me, that everyone is totally familiar with those two terms. So, I mean, I think in general the industry would accept that inline is essentially deploying a package of technology in the path of your transit circuit. So typically, it's that far north of the network or the point of presence to the internet where you would have your fiber or your cross connect that would come in from the transit provider. You would put it into this piece of technology, and then it would run southbound or at least be received into the typically what we are used to receiving traffic into, which is typically a router. But if you're not actually under that control, it could be a switch as well or something like that. So that's what we mean by inline. It's literally in the path of the traffic. The other term that you referred to there, data path or virtual inline, as it were, is essentially having traffic that will be received by the same technology or a similar technology platform. Could be virtual, could be physical, could be software defined on a routing platform, but it's not necessarily in that transit path. So it leaves the transit completely independent to do what it does on a fiber. What it means is that if you're in the data path somehow, that traffic will need to be engineered into that path for inspection and further processing, essentially. And that's essentially what we mean.
Now, when I'm looking at inline / virtual inline for deployments, based on some of the other things that we talked about, or actually even between these two, is there a difference in cost to deploy, right? Because if I'm going to do something, it sounds like I need to be at every point of presence wherever I have internet connectivity coming in. Are there differences in scaling capabilities between either of these two models?
There typically is a difference, probably a commercial difference between the two, but I wouldn't say it's significant. For me, the biggest difference is that the capacity that you deploy in order to mitigate or protect the service from distributed and denial of service incidents. With a virtual inline model where you're not in the physical path of the traffic, that capacity becomes decoupled to the network's connected edge capacity to the internet. So in its simplest terms, if you had 100 gigabits of transit and peering capacity to the internet, then if you were in an inline mode of operation, you would want to cover those 100, potentially 10 tens links from the internet, or the single 100 gig link on that transit path. Whereas if you were virtual inline, you could deploy, say, a discrete capacity of 20 gigabits per second throughput, but still maintain a much larger connected capacity to the internet. And there are specific priorities that may mean that you'd want to do that, essentially.
Interesting. because actually that wasn't the answer I expected. So I just learned something that we've come with a new vocabulary word, and I just learned that. So now, in terms of looking at, all right, I've got a box that's inline or virtually inline, but basically I'm in that data path, hence the name. Accuracy, false positives. How are we ensuring that we're keeping those to a minimum, if not non-existent?
Yeah. That is a good question. I mean, I think the problem, the two challenges that you described there, both the accuracy and the false positives, that is an issue and a challenge that's pervasive to the whole industry. So whether you're a network detection, an NDR platform, or an EDR platform for endpoints, or whether you're a discrete technology working at the edge like we are, then the ability to be, or the requirement to be accurate and to make sure that there are no false positive plays a huge role in both the software development process and the presentation of data to users so they can make good informed decisions. The way I like to think about it is that our business really is all about being the producers of a brain in software to be able to orchestrate the way in which network nodes behave and the way in which our own nodes behave. So once you have those two elements, what you've got to combine then is you've got to combine some experience in with that, and knowledge and experience of across data sets, across our own customer data sets of all of these incidents, thousands of potentially even, running into the millions of incidents that we've seen over those years, gives you a lot of insight into the teams of co-workers that we have that are dedicated just to work streams such as, efficacy. So how do we accurately perform these tasks without doing any harm at all? There's a couple of different data approaches that are used. I mean, I hear a lot in the industry at the moment about what is the potential use of artificial intelligence within the scope of in which we operate. Currently, the Corero's focus is entirely deterministic statistical machine analysis. So the data is there, therefore we will make this decision. And I think in our space, that is particularly important because as a network engineer, you really want to know why a tool did a certain thing and why it behaved in a certain way. So it's not to say that there won't be AI used, but in discrete and purposeful focused elements, essentially. In terms of sorry, Mark, I'll just finish that. It's okay. In terms of the volume of data, there's about, we work with probably twice the amount of data than most other applications for this task. And we have an entire data indexer just for the analysis process. And the reason that's required is because we do our detection completely differently using the entire frame to perform that analysis on. So that in a nutshell is how we focus our attention on accuracy.
Oh, that makes sense. And just something too that I found interesting when I joined the company is we originally got our start in the IDS IPS space.
That's
so
right.
We're still using
a long time.
Yeah, but we are still doing payload analysis too, which I found very, very interesting myself. And do me a favor, actually, I probably should have started here. When it comes to choosing all these different models, what is the motivator for an organization to say, I want an inline deployment versus some of the other ones that we've talked about on other sessions? What is it that drives that decision?
I think for me, it's about, there is quite a useful acronym for this. I think about it like this. I call it the FAST acronym. So bear in mind there's two A's in the word fast, but FAAST. You want if you're looking for the key characteristics of an ideal gold standard DDoS defense implementation, you want it to be flexible, you want it to be accurate and automated, because if it is automated, then if you are accurate, then you can automate. You want it to be scalable, so that's the S, and then finally your time to mitigate to be as low as possible. So if we can achieve all those things, then we're doing a good job. Now, if I want to make a case, if I was making a case to my management for which architecture I would like, I would probably go, and it would depend upon what I'm protecting. So for instance, if I'm a software as a service delivery business, and there's plenty of them now, some very, very large ones as well, then often they will take the gold standard in implementing DDoS defense, either in a virtual inline or an inline model, because the time, you know, the decoupling of detection and mitigation is condensed into one. You get to have a lot more visibility into what's going on, and so the actions that you take can be, you know, that next level more accurate, and so automation plays a key role for them.
Great. And actually, we had a question come in, so I think Marco, we just answered that question because he was asking what drives the decision for an inline deployment. So I think we answered that. If not, please feel free to, you know, chime in. So again, keep those questions coming. I also have a poll, another poll that I put up. So, you know, all right. So let's get into this. I mean, I think we talked about it a little bit, but I mean, if you could get into performance advantages, you know, particularly around both. I mean, I think we're looking at maybe advantages, differences. I'll let you answer that out. But with inline in general, but then also too, you know, we also, I know for us, we have hardware-based, virtual-based, you know, so as we're talking about this, you know, what are some of the distinctions, trade-offs, advantages? And then I'm gonna have to do it, but how do we stack up there compared to the competition?
Okay, sure. So let's get into it. Let's talk a little bit about performance. And I think packaging performance into a vendor's hardware platform has been a popular choice for both the consumption of DDoS protection, but also just as a way to go to market. And it's not necessarily because there's any requirement to package software onto specific, you know, often referred to as tin, if you like. But there's a lot of practicalities and sensibilities with it. For instance, the QA process will guarantee the performance under, you know, certain conditions for a hardware platform. Whereas if you abstract the hardware that's being used for the processing in, say, a virtualized world where you have a range of different hypervisors performing functions that are taking packets from a network card, putting them through user space, and then getting them to through the kernel to the processor as fast as possible, you've then got a lot more variables involved. And so inherently there is a performance drop when you start to virtualize and think about applications for this task that's not on you know, tin that's been guaranteed to a certain performance level. Essentially, we have a team of people dedicated towards deploying software just in a virtualized world. So, you know, we have the luxury of experience and knowledge in that area. Specifically at the moment, we're looking at the all-important measured feature of packets per second, and that's really important because the volume throughput is relatively easy to deploy under certain basic conditions, but packet throughput tends to be much more of a challenge, and is the measure by which you'll look at forwarding planes on, you know, routing line cards and things like that. So for us, we know, for instance, that we have like a 40% increase over the competition right now on our virtualized platform, which is a great place to be. But the practicalities of deploying a virtual platform, it's not for everyone. But there are some very good use cases for it.
And I'm curious, what's the breakdown? Do you ever see, you know, like, is there an industry or a by industry type of trend, like that prefer virtualization over hardware? Is that ever an issue that we must have virtual?
I think it is. I think you know, high availability requirements come and play a role in this one, and that's often dictated by, you know, networking policy sometimes. But I see it a lot possibly within the hosting provider space, where they're used to providing, you know, bare metal tin and hypervisor implementations for people to put their own stacks on top of, because they know their hardware really well. Sometimes they even run it on their own configuration so that they can guarantee the performance to their end users. But they will often take the virtual choice rather than having a pre-packaged piece of hardware that will arrive.
Okay, and we did have another question come in. So it's asking about how to offer DDoS protection as a service. So we did do a webinar on that, and Marco, I'll get you the link. Or actually, it's here in Bright Talk. Actually, you'll be able to see it probably quicker than me doing it. But to Marco's question, you know, when we look at these architectures, you know, is there a preferred architecture when you're offering DDoS protection as a service? Do I want to be inline? Does it matter? or what are the choices that would lead me to pick
Yes, I think there
any
is.
of the architectures?
Well, ultimately, it depends if you want to differentiate yourself from your nearest competitors. So it's very easy to see what your direct competition are offering in terms of protected transit services or protected hosted application services. Go in there, check out the SLA, and often they're actually they're a fairly low bar if you were trying to exceed the expectations of the customer in that sense. And this is why a lot of people are going in this direction. But one very useful feature that will allow you to far exceed your competition's capability with DDoS protection as a service is the ability to take customer traffic and either create a tier of service which will allow for the inspection and treatment on an on-demand basis. Alternatively, offering the customer the ability to inspect that traffic all of the time and be able to mitigate that traffic in as small of time as possible. And with the technology that we work with, Mark, that's almost instantaneous. It's barely measurable. But having those two options gives the customer choice. It allows them to make informed decisions about what risks they're managing. And both an inline model and an in-path model, sometimes referred to as virtual inline, will allow you to achieve both those two things. Now, with the inline model, you're achieving that in software, but with the virtual inline model, you're achieving that via traffic engineering techniques that teams at Corero can help implement.
Can we drill into both of those real quickly? So when you're talking about implications with traffic engineering, can you just get into that a little bit, explain what you're talking about here and what the impact there is?
Sure. Well, it depends upon what the ecosystem you're deploying into is. So what routing vendor have you standardized upon? What does the network edge look like? But broadly speaking, one of the simplest ways to engineer traffic is perhaps a filter-based forwards or a policy-based forwards into a place where we can perform our inspection and forwarding tasks. Now, in those forwarding statements, you build in engineer in choice for the prefixes that are either paying for that service or the prefixes that you want to protect. So for instance, you'll say customers A, B, and C, or prefixes, /24s, they will just go to their normal destinations. But all these other prefixes here, they can go for inspection, either on demand or always on. And so it's that flexibility in that model of fast, sort of flexible, accurate, automated, scalable, time to mitigate being low, that flexibility piece, that gives you the choice. And actually, with both the models that we're talking about today, you can perform, both of the tasks we're talking about here.
Great. Something else, just as an aside, I guess around the topic of scrubbing, right? So we did a session talking about where you might want to place scrubbing centers and so on. And then it was, I swear, within the next day or shorter, I saw something internally about onboard scrubbing. Would you mind talking about that a little bit?
So just so I'm clear then, you're talking about another deployment model that we sometimes refer to as scrubbing.
Yeah. Okay. And yes, and that, I guess, maybe help me understand. Maybe I'm the only one here, but I'm thinking of scrubbing as, okay, this goes off to a scrubbing center. Like I've got the volume where I want to redirect traffic to be scrubbed before it comes back through my network. And then but I saw something in there, and I hope I'm not putting you on the spot because this is a completely unscripted
go ahead,
question. Yeah. But just to say that we're able to do scrubbing basically on board one of our devices. So even if you don't have a scrubbing center, and maybe it's just the definition for me, but if you could, does that make sense? Could you talk about that a second?
I can do. So essentially, I think what you're probably referring to there is, when I think about scrubbing, I think about throwing something in the wash. It needs cleaning. We've got to send it over there, and it's going to come out in a lot better condition than when we sent it in, essentially. So scrubbing probably technically refers to the process of decoupling that detection element. So work out what it is that's happening and then work out what we need to do to it to get it fixed. So when you're scrubbing, you're essentially saying, I'm going to be performing detection all of the time, and then I'm going to make an informed traffic engineering decision to send it for cleaning, but that's going to be on a just-in-time model. So it's, I need it now, send it now. I'm finished with this, take it out again. Now, when we talk about the models that, the purpose of today's discussion, which are inline or virtual inline, they are typically used for the gold standard of DDoS defense, which is to simplify the models, to make them to be super fast in all functions, but you're not decoupling that detection piece. So you typically have traffic, always inspected when you're inline, or when you're virtual inline, you can have certain prefixes always inspected, but maybe not. You're not inspecting all of the prefixes. Okay, so that detection piece is still going on, but it's in the path of the traffic. It's not going on and then triggering an on-demand action to send traffic for cleaning. Sure. There is a very subtle difference, but important when building a service.
Yeah, exactly. Okay, so we're actually burning right through this. So I'm going to put up the last poll right now. Okay. And then what I wanted to ask you about next, Pete, let me just, as I'm going through this, I guess, everything has a trade-off. And when you're talking to customers about what model to go with, and they look at inline, I guess, what are some of the common concerns that you hear around inline deployment? Because I mean, the first thing I think of, inline versus the virtual inline, but maybe both. But okay, what happens if our box crashes, for example? But I know that's one, but could you talk about what some of those concerns are that you hear about and how you respond to those concerns?
Sure. Well, I mean, we do we do a lot of agreeing, and we have a lot of options. So essentially, it's actually a very physical issue. So we have failover mechanisms for an inline model. Pretty much all of the packages that we deliver our software on, so we're talking about in appliance form, mostly here, we have ways of allowing the light on that fiber to continue its journey to its destination, even though there's been a failure, a potential failure situation, both physically with the hardware or within the software. So physically within the hardware, we have a light path failover model, which won't drop a BGP session. It will reliably allow that traffic to flow, even though there could be the eventuality of a physical problem on that technology platform. From a software standard, we have this kind of model and development mantra of do no harm. And that the best way to think about that is that, we do not want to drop packets unless we're 100% sure that this should not be forwarded on our forwarding plane. So when we develop our efficient pipeline models of packet processing, this do no harm approach to this allows us to say, okay, we've done all these checks. If we're not sure by this point, then we're going to forward that packet. And allowing a little bit through to the destination is far better than dropping a packet and then not declaring that packet, which is what a lot of times technology deployments under stress, so firewalls, WAFs, things like that, which are being repurposed for this problem, will be the element of choice. And performance under duress is what DDoS is all about. So having engineering decisions made into the tool like that help a lot, I think.
That makes sense. Okay, so we've got a couple more questions to come in.
Sure.
I think that should just give us enough time. So
one of the things we haven't actually touched on, Mark, is just on that performance figure. I mean, there have in the industry there have been fortunes made based upon using application-specific integrated circuits, or ASICs, that some people might be familiar with. And I certainly don't claim to be an expert on ASICs, but I do know that when they are applied to a specific application, they are extremely fast. But that is if the problem is very specific. The challenge with DDoS is that it's not problem specific. We often have threats that change in their shape. We think of us like you need to be kind of a malleable IP stack where you need to remove the threat when it behaves in situation A, and then when it changes and behaves in situation B. So having an ASIC dedicated to a specific task could be really fast and could be a great idea, but is often why we actually deploy upon slightly more flexible architecture, which allows us to keep our development in line with the changing sort of, for want of a better phrase, threat landscape, if you like, in terms of DDoS.
Okay, cool. Thank you. All right, I think, so let me just go through a couple of these questions. Some of them I think by we, I mean you, have answered. Hardware failure, we talked about that. We just talked about that. Clarifying traffic engineering. Okay. Okay. So I think there's just one other of these questions to put to you. So under what circumstances would you recommend a virtual inline deployment over dedicated inline appliance?
For me, the tipping point is connected edge network capacity. So, for instance, I know that I can deliver quality, gold standard DDoS protection as a service to our customers if I'm given a discrete capacity and some basic traffic engineering. We do this on a weekly basis for our customers. But that tipping point really is the connectivity to the internet. So, and that differs for everyone. You know, as the cost of 100 gig ports comes down and the cost of committed data rates to our on our transit circuits comes down, it's often a balance between whether or not we want to deploy inline at 100 gig or even more than that in certain circumstances, or whether we want to keep our diverse connectivity and peerings at, say, tens and then move them gradually to 100 gig interfaces, because sooner or later, the S in that acronym FAST, the scalability, becomes the key consideration. The good news is, however you deploy, a model, both technically and licensing model, is actually flexible enough to adopt that. So if you get to a point where you think this is just not going to scale, you can start down the inline route, and then you can switch over to data path model with really virtually no impact to a change in decision, apart from the effort to make that change in the first place.
All right, perfect. Well, Pete, thank you. I appreciate you taking the time. We're just hitting the holiday crunch, so I appreciate that. Thank you to everybody who's attended today. I did put an announcement. If you would like to speak to one of our specialists, such as a Mr. Pete, please go ahead, click that link, and we'll get some time set up with you. Other than that, I think we'll call it a wrap. So thanks
everybody.
All right,
have a great Christmas.
Bye-bye.